Hello, everyone, and welcome back. This is now the panel discussion on the human RF exposure limits, and we're pleased to have George Kizer with us, who you met earlier. For those of you who might not have been on board earlier, George is a board member and past president of NSMA, as well as a key influencer in TIA, FWCC, and a variety of other areas of microwave and RF management leadership. Justin Daviault is also with us, and Justin's a field application engineer with Anritsu, and Justin will be helping us understand exactly how you do operate an RF exposure spectrum analyzer type of device. We'll first start with George, and Justin, if you're able to, if you can mute your microphone, that'd be awesome. All right, George, take it away. Thank you.
Okay, thanks, Joe. Can everybody hear me? Joe, can you hear me?
Absolutely.
Great. Now, I assume everybody can see my slides. Yeah. So let's talk a little bit about RF exposure. As I mentioned earlier today, historically Part 101 fixed services have been exempt from RF safety studies related to RF exposure. However, in the end of 2019, the Commission published a new order stating that the criteria for RF exposure evaluation has been changed. And although I'm saying these rules are pending, they are not. They have gone into effect as of May 3rd. The interesting part of this is that all facilities regulated by the FCC, including licensed and unlicensed, are subject to this rule. And effective May 3rd, you have 2 years to evaluate your RF links to see if they comply with these standards. That's quite new. We've never, in Part 101 and in the unlicensed bands, we've never had to do that before. Now, all links have to be evaluated, even if they're existing. So within the next 2 years, you have to evaluate all of your links and see if they comply with these new requirements. And I'm sure that that's something that everybody is looking forward to doing while they're doing the deployment of services to support 5G. I'll leave that to your discretion on whether or not you think that's a good thing to do. There are 2 methods of complying with the with this new ruling. One is to qualify you as exempt. If you're not exempt, then you have to do an evaluation. And first, we'll have to talk about what is exemption. A service is exempt if you calculate your EIRP being lower than what is described by the factor that's over in the right-hand side of the graphic. In other words, if your EIRP in watts is less than 19.2 times the distance between the transmitter and any possible person, that distance squared, then you are exempt based on that calculation. Now that's very interesting because the Commission says that if you are low EIRP, you're not a danger. But in fact, physically, for aperture antennas, it's the low EIRPs that are the danger, not the high EIRPs. So I hate to mention it, but the FCC has this, from a physical point of view, they have this backwards. However, I'm not the FCC. I didn't get a choice. These are the rules. If you pass this calculation, if your EIRP is less than 19.2 times distance squared, then you are exempt. Let's suppose you're not exempt. You will go through the calculation. Here you normally you calculate EIRP. That's what most programs calculate for you. They usually get EIRP and dBm. We convert that to EIRP and dBW. Then we go through here and convert that to ERP, which is what the commission is interested in. And then we convert that to watts. And then we see if we pass that 19.2 times R squared criteria. And we have to do that evaluation of all links in the next 2 years. So what do you do if your transmission facility is not exempt? Well, first of all, let's not get too excited about this. We're talking about electromagnetic radiation. Typically, our radiation is on the order of from a tenth to 4 watts of electromagnetic radiation. I would like to point out to you that your large traditional Christmas tree lights put about 7 watts of electromagnetic radiation, most of it in the infrared band. And nobody seems to get very excited about a whole Christmas tree full of these lights. And they're putting out a tremendous amount of electromagnetic radiation. But somehow people get really excited when they see those big dishes on towers. Well, we don't really represent a hazard to humans, but we have to prove that. Okay, we got in the RF business, we've got circular antennas, and we've got panel antennas in the unlicensed bands. And we have to do an evaluation of both of those to see if we have a problem. Well, we know that when you get very close to an antenna, you're in the near field of the antenna. Now, there's a reactive field that's within about a wavelength of the front of the antenna, but there's no rational way that anybody's going to get involved in the reactive field. You're really concerned about the radiating near field of the antenna. If you look at the radiation from an antenna, we're looking here at the near field radiation of a circular antenna. As you get close to the antenna, all of the radiation is centered at the center or bore side of the antenna. So directly in front of the antenna is your maximum radiated energy from that antenna in the near field, which is what we're concerned about. The limits for near field radiation for the general population or uncontrolled areas is 1 milliwatt per square centimeter. If you're saying that you have a controlled exposure area, you can have as high as 5 milliwatts per square centimeter. We will focus on the general population or uncontrolled exposure areas. Now, the 1 milliwatt per square centimeter for uncontrolled or 5 milliwatts per square centimeter for controlled is pretty much a worldwide requirement. We're worried about considerations in the U.S., but the truth of the matter is these same requirements extend for the frequencies that we operate in. They extend worldwide. So we're talking about very general limits here. Occupational exposure limits are those where the person who's irradiated is fully aware of the potential for exposure and can exercise control over exposure. The general population or uncontrolled exposure limits are where people might be irradiated but may not be aware of the potential for exposure or cannot exercise control over their exposure. So those are the two types of areas that you're considering when you're looking at RF exposure. If you have RF exposure, depending on the level of exposure, you may use some signage to indicate that. Here are the 4 different types of signs typically used in an area depending on the level of exposure. If you're category 1 or general population limit of 1 milliwatt per square centimeter, 1 milliwatt per square centimeter, you don't have to have any signage at all. If you want to, you can add informational signage. But if you exceed that limit, now you have to start adding signage depending on your level of exposure relative to the general population limit. The good news is that it's fairly easy to calculate the necessary exposure for different types of antenna. I've gone through the calculations, and if you're in an uncontrolled area and you have a parabolic antenna or a square antenna, this is the maximum power that would be applied to that antenna that would just meet the 1 milliwatt per square centimeter density limit. Now, if you can't meet that, you would consider adding 7 dB to these values and see if you can meet those. So hopefully you could at least meet the controlled area limits, but then you would have to have some additional signage, and you would have to control the area, limit the way people can get into that area. In general, we want to be meeting the uncontrolled area limits if we possibly can. Notice that the limits become much more stringent when you get small antennas. The small antennas have very low EIRP, but they have relatively high power density because you're spreading the energy over a much smaller area. That's a counterintuitive result, but it's the way things work. I'll point out that the only direction the Commission has given us today on calculating RF power density is in the Bulletin 65. And I'll point out that, first of all, it only covers, for our types of antennas, it only covers circular antennas, and its equation is wrong, and it doesn't cover square antennas at all. So I would recommend you go back to this chart to do your evaluation. It's perfectly obvious that the Bulletin 65 equation is wrong, because the equation says that as illumination efficiency is reduced, the power intensity is reduced, and that's obviously completely backwards. As the illumination efficiency is reduced, power is illuminated more and more in the center of the antenna, which increases the power density. So unfortunately, Bulletin 65 has the whole process backwards. Nevertheless, I've given you the real results on how you would calculate whether or not you're compliant with the FCC's rules. That's all, folks. Are there any questions on the new rules that you get an opportunity to use in the next couple of years? I'm sure everybody's aware of that and off furiously evaluating paths right now.
Thanks for that. Was that Warner Brothers?
Yes, it is.
Yeah, I love it. I love that. Well, thank you, George. And I'm sure we'll probably be doing some questioning at the back end of this. But in the meantime, and there's a bunch of emojis rising up. In the meantime, if we can get JD to talk a bit about how you practically do these measurements that George was talking about. What kind of equipment is out there? And you have a sample piece of equipment you can talk to us about, JD. And we'll have to get you off mute and get your I think you have some slides you're going to show us.
Yep, I just got to wait for George to take his down, because only one person at a time.
Okay, gotcha. All right, so George will be taking his down. We'll get yours up. In the meantime, I'll just do some verbal about, I will speak to a little bit later, everything George talked about, and presumably the type of compliance that JD will talk about. The FCC came out with a bulletin on Friday, Friday before the show, which tries to encapsulate a lot of these requirements as well. And there's a couple different nuggets there, but I'll hold off on talking about those while we get JD up to speed.
I'm just waiting for my slides to go up. I clicked on everything. It's sitting there, thinking about it.
All right. Well, while it's in JD, can you give us a preview of what type of area you might be talking about?
Well, basically, I'm just going to be talking about the testing, being able to go through and actually test what is that level. we can do calculations, and calculations are a great thing, but nothing beats actually going up with a sensor and saying, here's what it actually is at this specific point. And I remember a case, it's probably been about 10 years ago now, where there's a large transmitter facility just outside of Los Angeles. And for whatever reason, the FCC was running around the area that day, and they found a gate unlocked up there. Because that gate was unlocked, they went in and checked RF levels and found that they exceeded public exposure level. And because they exceeded and someone left that gate unlocked, they turned around and fined every station up there based on the percentage of power they contributed to that violation. Like I said, that's been a good 10 years ago, but it still does happen. If you have an uncontrolled area, you really need to know how much radiation is actually there. And we might need to get your counterpart online here, because mine is just sitting there spinning for some reason and not uploading the way I thought it would.
All right. Well, I'll reach out to Mariana and James. Maybe Mariana can. There she
is. Thank you, Mariana.
Thanks, Mariana. All right, JD, go for it. And just
okay. I want to be talking about just electromagnetic field strength with our 2090 and a couple of the different options that we have. Go ahead, next slide, please, Mariana. Basically, we're just going to do a quick overview and a few other things. All right, so go ahead to the next one. EMF, obviously, is a measure of the RF radiation compliance with various national and international standards. And the ICNIRP, the International Commission of Non-Ionizing Radiation Protection. Basically all the stuff that we transmit as opposed to the ionizing stuff, gamma radiation and a few other things. Next slide, please. And here's the basic spectrum. You've got your non-ionizing from 100 kilohertz up to 300 gig, let's say. You can see a lot of that. And eventually you get into your light and then your ionizing. And of course, visible light is that teeny little one in the middle of all of that. Go ahead and go to the next slide. But what we're going to talk about is basically going to the 300 gig. And just when you think, 300 gig, no one's transmitting 300 gig, just wait. You'd be surprised what people are actually using and transmitting right now. And as we get more into the millimeter wave, people have a tendency to overreact to the term microwave just because of the size of the wave, and they are concerned about everything. And rightfully so, you should be concerned. But sometimes they overreact a little bit, and you have to be able to go and say, look, this is within spec or this is not within spec. Very simply. And because the public's concerned, and it's going to only get worse, or more concerned, I should say. Go ahead to the next slide. So there are two primary users of EMF measurement instruments. Obviously, your regulators and your operators. And in our case, we're pretty much dealing with all of the operators here. And not just the Docomos and the Verizons, but anybody who has a transmit facility of any kind needs to make sure they're in compliance. Especially now that there will be a lot fewer people that are exempt, so to speak. Let's go ahead and continue on. So, obviously, George talked about it. Power density in meters squared or in centimeters squared, depending on which way you're measuring. General public limits and occupational limits, it's sometimes called technician. Go ahead, continue on, please. Next one. So occupational and general public, they follow each other, but they're, a little bit apart, about 5 times more. So, sorry about that. I have to keep my phone on. I got other things, family things going on. Anyway, let's go to the next slide. So EMF measurements, we can do them 2 different ways. We have a set of probes that hook directly on top of the spectrum analyzer, And these are banded based on certain frequency bands. And these are isotropic, and they can be used with one of our spectrum analyzers. Go ahead and go to the next slide. And these all go up to, different ones up to 6 gig. It's basically nice isotropic. It's controlled by the USB, and it'll measure your power density. Very simple, very straightforward. You don't have to worry about manipulating it around a whole lot. Go ahead and go to the next one. And in the one aspect, this does it where you're actually looking at it by frequency, by individual frequency, and you can look at what the limits are by individual frequency. Go ahead and go to the next one. And some of the practical applications, they'll actually set one out there and then measure for a certain amount of time, normally to about a minute. And then they'll move it up, down a little bit, just to make sure that everything is in compliance. Go ahead and go to the next one. One of our newest ones is a probe that you see here, and it has only a USB connection to the spectrum analyzer. This is a wideband probe, basically going all the way up to 40 gig with one probe, one measurement. Go ahead and go to the next one. And we're not the only ones that make stuff like this, just so you know. The probe is wideband, 20 meg to 40 gig. And you can literally walk around and take multiple measurements and verify, yes, we're in compliance or we're not in compliance. And the nice thing about having a nice big spectrum analyzer, well, it's not that big, it's portable, thankfully, is once you know that there's somewhere that's not in compliance, you can turn around and go to the spectrum analyzer and say, okay, which frequency band is this? And where is it exactly coming from? You know, who's contributing to this problem? Go ahead and go to the next slide, please. And one of the major places that we're going to have a lot of this, at least for people who work in the industry, is rooftops. Where's everybody putting their stuff? Up on the roof. They're going from building to building with microwave. They're going from, you know, all of your operators are going up there. And sometimes, as it's stated in the slide, some of the building residents have rooftop gardens, and you need to make sure they're not going to wander to wherever the RF is. Go ahead and go to the next slide. I mean, signs are lovely and great, and from personal experience, we actually had signs up on a site back when I used to work for Sprint, and that didn't stop some guy from going in and mounting a traffic camera in front of the antenna, 6 inches in front of the antenna. He must have been leaning on it when he was installing it. So not everybody can read these signs. And it was locked. It was a locked access, and still these things happened. Now, this is just a quick case study. You can see in the background, you see these big green pillars. Well, in this one locality, they're required to cover the antenna to make it look pretty. Go ahead and go to the next slide. Well, we have a couple of legacy LTE radios that we're going to be that they looked at. But now, you have to remember with this 5G, some of these people have got some very, very high frequency. 28 gig. So start thinking about that. 28 gig millimeter wave. And there are people up in the 30 range and the 40 range where they have licenses. So they're going to be radiating this. And think about what George was talking about and the inverse square law. I like to use the inverse square law when it comes time to start thinking about how far my signal is going to carry and things. And the inverse square law just basically says, when you leave the aperture of the antenna, that first wavelength, you drop approximately 22 dB, and then every doubling of distance from there, it's another 6. Now, if you're into little things like ham radio and stuff like I am, we all know that the VHF band in the 144 or 148 ham band is called the 2-meter band. The reason it's called 2 meters, that's the length of the wave. So if I'm transmitting 5 watts out, I know that it's going to go 22 dB down at 6 feet, and then another 6 dB at 12 feet, and then at 24, and so on. But think about these 28 gig radios. How much power do you have to push from a rooftop to get it to ground level? And how much power, and the handhelds are going to be very limited in how much power they can push back. but how much power are you going to have to push to get that coverage that they're going to want? And just when you thought it was safe to go on the roof, a lot of these installations are going to be disguised inside light poles at street level. So 5, maybe 10 feet above your head will be a possible 28 gig transmitter. And these operators are going to have to test and verify that no one can accidentally wander into an area. Let's go into that next slide, please. So one of the ways you can do it is you can take it and you take your measurements. Now, this is a nice wideband measurement. And they call him the fearless technician, apparently, because he's standing in front of this 28 gig. But it's a 30-second measurement, and he just slowly goes up and down. Go ahead and go to the next one. And because it's a wideband measurement, you're not having to worry about different frequencies right off the bat. What you're having to worry about is just, are you within spec or not within spec? Go ahead and go to the next one, please. And this is just a picture of the screen, and I don't know if you can see my mouse, but if you look at the very first column, you'll see there was almost nothing where he took the first measurement, and there's a small purple blue line down there. That was the max during that measurement. Now if we go to this, and these are just different measurements, first measurement, second measurement, third measurement, so forth. You can take multiple measurements, multiple spots. So measurement 9 was a good pass. You look at measurement 10, the next one over, well, it looks okay, except somewhere during that measurement, it jumped to over 110% of permissible exposure. So somewhere in that area is obviously a hot spot that we can't let people get into. And then the third measurement looked okay, and that fourth measurement, it was getting up there, but it was still underneath the standard exposure limit. So nothing beats being able to actually test it personally. Go ahead and hit that next one, please. And if you're outdoor, and Joe and I have talked about this for indoor stuff, but if you're outdoor, because you can have a GPS on some of our stuff, you can actually mark and have GPS coordinates of where you mapped and what the readings were using, your standard Google KML type stuff. And we're working on some stuff. Joe and I have been talking about indoor mapping of this kind of thing, because just when you thought it was bad outdoors, you can go ahead and go to the next slide, please. But I want you to think about this. All these cellular operators are trying to get coverage inside. So not only do they have everything blasting around outside, all these new buildings are built with things like low-E glass. Low-E glass has about 50 dB of attenuation through it. So you could have a transmitter right on the other side, and you got 50 dB of attenuation before it gets through that glass. So getting the signals into the buildings where people want to use stuff is getting to be a little bit more of a challenge. So they're doing a lot of in-building systems. So now you've got in-building radiation. Now it's supposed to all be below the limit, but you're going to have to go and you're going to check. And not only the cellular operators, but now the National Fire Protection Association, the NFPA, has mandated in a lot of cases, and different states are adopting it different ways. But you have to, if you're building a new building or verifying an old building, you have to verify you have coverage for police, fire, and EMS. So now you're getting more systems being installed into buildings and more buildings being checked for that radiation, because they want, your first responders to be able to communicate. You can go ahead and go to the next one, which I believe is the last one. Okay. We can go ahead and pull those slides down, and we can have a nice little roundtable discussion about, all right, who wants to cook in front of the microwave antenna, and just as you start to laugh about that, just to give you a 10-second history, when I first started out in RF, I was in the Air Force back in the 80s, and I was in what we call radio relay or wideband, and I used to have antennas, parabolic antennas that we would set up. I'd pump 1,000 watts out of them at 4.4 to 5 gig, and you could take a stick and you could cook your lunch in front of the antenna all day long.
Well, thank you, JD. Glad to hear your view from the front lines. And I have a couple slides, a few slides just to go through that sort of take into account the item that the FCC just released on Friday. Basically, that item is the let's see if you can see my slide, is their what's called small entity compliance guide. And it, as you can see, if you can see my cursor, it was released May 14th, 2021. It tries to summarize a lot of what George was talking about. And then, of course, what JD was trying to talk about, how do you practically comply? So I should, it's not a new rulemaking order or anything like that. It's just a compliance guide built around the order that George talked about. And, of course, what JD's talked about in terms of how do you effectively comply. One thing that matters from a legal standpoint or a regulatory compliance standpoint, there's a few things that are interesting in there. One is they made sure to state something about NEPA. NEPA is what's called the National Environmental Policy Act. And they basically said, and here's the eye chart language, but they're basically saying, look, you don't have to create a formal environmental assessment as many other folks do in other industries, because we have our own set of standards for complying. But there's some wiggle room there, and we'll get to that in a second. They also talked about what George talked about, and I won't go through this in detail because George did such an amazing job, about the FCC methods. You can either comply through exemption, evaluation, or mitigation. One thing I'll draw your attention to is at the very bottom, the FCC has noted that they have something called a knowledge database, or a KDB. And what's interesting is that the FCC has removed IEEE standard C95.3-1991 from its rules as a possible SAR, specific absorption rate reference. So the FCC is now only relying on its own KDB knowledge database. So a lot of folks past practice, and I was doing this at Windstar in the 1990s when we'd send people to roof, 8, 10, 20,000 roofs, that was all IEEE based. So, be aware that there is some shifting here, and check in on your KDB. I'm going to the next slide. George already went over all the signage, so I don't need to go into that. Two other things just to be generally aware of. The FCC's in court. It's been sued. This is one of many locations where it's in court. This is the federal court, United States Court of Appeals in the D.C. Circuit. What you see here is just a picture of an oral argument earlier this year, the notice of oral argument, Environmental Health Trust, and something called Children's Health Defense petitioners versus the FCC. So this is in somewhat of a pressurized situation. So another reason why to listen to what George is saying, what JD's saying about pay attention, because one, we've got the FCC's attention on this. The FCC's issuing its new guidelines. Be real careful, really pay attention. And two, this is under pressure. It might become stricter. So, be aware. There's another element to this is one of the challenges is based on a letter that went from a gentleman named Jeffrey Shurin, who's a director at the Center for Devices and Radiological Health at FDA to the FCC back in 2019. And that was the basis, a main basis on which these rules that George was discussing, the FCC based it on. They said, the FDA says this. This letter's under pressure because the critics of it are saying this letter wasn't generated through an APA or Administrative Procedures Act process. It was just a letter. Now, is that accurate or not? The courts will figure that out. The critics and the folks defending the FDA standard will hash that out in other venues. But the point being, we may end up with a whole nother realm of studies out there. So again, coming from the FDA over to FCC or some other organization, some other federal agency, or a multiplicity. So stay tuned on all that. Just want to make everyone generally aware of that. And then I'll stop sharing the screen if I can figure out how to do that. There we go. Okay. All right. So now we're back to JD and George. George had mentioned something really important: Christmas lights, 7 watts. So I think what would be really interesting is, I don't know if JD and George, like if you guys got to spend time in a room with some Christmas lights and to measure those and measure other things, is the wireless industry, being made into a boogeyman when there's these other much larger radiators out there? That's sort of one question. I'll leave the floor open on that. I don't know if you guys have any thoughts on that.
Well, certainly for the fixed point-to-point community, where we're radiating no more than a couple of watts from our antennas max, we're definitely being treated as the boogeyman. People see these large antennas on towers, and they think, "Oh my gosh, I'm being irradiated by intense energy. I'm gonna grow 3 heads or die or get cancer or something," and that's just not true. We have been in existence. Microwave systems have been in existence since the 50s. There is no documented case of any environmental hazard to anybody from these systems, and that remains the case. In most cases, it's easy to demonstrate that the maximum power density from microwave antennas is less than 1 milliwatt per square centimeter. And in the rare case where it's greater, it's only slightly greater. So we generally meet the environmental requirements, and we don't inflict any hazard for anybody working around fixed point microwave.
Yeah, point to point especially because the path is so well defined and the dishes are concentrating everything down the path. It's really hard to, unless the antenna falls over and starts shooting at the ground. On point to point especially. I mean, oh my goodness, they don't allow very much power at all. When I tell my stories about the military, we're using a type of microwave called troposcatter, where we actually would diffract off the troposphere 2 times and go 300 and 400 miles.
Wow.
So that's why we used high power. But the small point-to-point microwaves, oh my goodness, you probably have more leakage in your house coming out of your microwave oven because you don't close the door properly or you slam it too many times. And then you got your kids with their face pressed up against the glass of the microwave. Good God, I used to snatch my kid away from that. Get away from there, are you nuts?
So yeah, and so that those kinds of perspectives are valuable, and as we roll into this environment of more and more focus and interest from all sides, these are engineers, spectrum managers can provide a needed clarity as to what is really happening, and so fixed wireless seems to be a lot safer, in terms of its effects than what a lot of folks see visually. As George mentioned, a big antenna means less likely power is going to be dispersed all over the place, et cetera, et cetera. Those are hard and fast rules of physics and electrical engineering. That said, we do need to pay attention. There's all kinds of other systems out there that may or may not be compliant. We do need to measure. I think it was mentioned earlier, but to reemphasize, and it was reemphasized in the FCC's compliance guide issued Friday. If you're a licensee, or you're representing a licensee, or you're selling equipment to a licensee, if you're contributing 5% or more to that location in terms of the RF radiation, then legally you're on the hook. So that means, again, think about this from a regulatory or risk management standpoint, whether or not the industry is fairly or unfairly under pressure. The rules are the rules. And so as spectrum managers, we're, and as engineers, a lot of us are engineers, when you're an engineer or spectrum manager, when you attest to something on an official report, you're reporting it out. And so if that's line 3012 on a report, it might need to put that in your opening summary as well. Like, hey, we noticed something here that you might want to be aware of. These are the kinds of things to keep the industry compliant, keep everyone well aware of trends, and there's more to come here for sure. The other thing is the FCC standards, and George had mentioned, we're not seeing any documented cases of the FCC standards being violated. There's a whole nother discussion that we don't have time for in this segment, but we'll definitely talk about. The FCC's bulletin only talks to something called human, which means, if you're a if you're a farmer and you raise a specific type of basil or whatever, and you're using grow lamps or whatever, presumably if the grow lamps are harming your basil, then you're not going to buy those grow lamps anymore, right? The grow lamps may or may not be doing something to your human workers, though, so you might need to get that measured. But presumably down the road, I think we're in a situation where we're going to start seeing more and more folks looking at, well, how does this impact other parts of our food supply or something like that? And of course, FDA is looking at medical devices, and there's more and more of this Internet of Things everywhere, on our clothes, on our pets' collars, go down the list. So, in terms of a big picture, I think in a way to make some lemonade, some of this is lemons, and some of this is lemonade. Spectrum managers and the skills that spectrum managers have to bring clarity to what's actually going on, I think are in greater demand. And we heard this Tom Fagan's presentation yesterday. He can't make enough certified spectrum managers, and it's and so again, I think this is a good forum to discuss rationally and with clarity and engineering precision what is happening, what is the gear out there, how do you analyze it. We had Tom Brockader yesterday, and he said he put some Anritsu and some other gear on his various drones to do RF measurements, and maybe we'll be doing RF measurements on drones not just for the feasibility of closing a signal or feasibility of building a fixed wireless or other link. We might be also doing it for spectrum sniffing for RF compliance. So I just want to throw that out there for you guys to reflect on. And any thoughts from George or JD on that subject?
Yeah, I mean, I've worked with Tom Brickotter in the past. He used to work for Anritsu back in the day. Had a lot of fun doing some different studies here and there. And drone studies are one thing. They're being used a lot now on towers. Rather than have someone climb, they're sending the drone to photograph and check the towers, believe it or not. And so those can be handy. And then there are other things. There are spectrum analyzers that you can place in the field that are designed for outdoor, where you could put them tactically around an area and then just monitor. So there's a lot you can do.
Yeah. All right.
We have some comments on the chat. Tom Willis would like a link for the new rules, and I'll add that to my slides and resubmit my slides, so that'll be available to everybody. And Harvey List says that there's been some discussion on microwaves being weaponized to injure U.S. diplomats abroad. That's apparently true, and there's a 94 gigahertz active denial weapon ban for crowd control. So microwaves can be misused. And yes, all of that's true. Justin mentioned troposcatter, very high. I mean, we have the capacity to generate immense energy in the microwave bands. Fixed point-to-point microwave doesn't do that, but it's certainly technologically possible to generate lots of energy, and it can be misused. But for our licensed applications, that's not the case at all.
Yeah, and I think that goes back to a really key point, which is we are guardians of how equipment is operated, and appropriately licensed and authorized and measured and complied with. And as Harvey mentioned, there's other, and this will be in a presentation later today. Yeah, there's other uses that in the past that are designed to harm as well, besides those. And so that's obviously for the fields of war or whatever, not for watching a video game, hopefully. So. All right. Well, I know we've gone a couple minutes over. Appreciate everyone's comments. I also do have a link to the new bulletin in the slides I put up. George will put the links to the rules in his slides. We have JD here, and there's many others, as JD mentioned as well. Other manufacturers providing spectrum analyzers for the community, so we can look at calibrated instruments versus something you buy for $29 off of Amazon. Use calibrated instrumentation, I guess, is the recommendation, right? So you can tell your bosses with some confidence that you're using a reasonable spectrum analyzing device for your license operations. And thank you all. We'll have a lunch break. We'll come back at 1 p.m. with Harvey List, radio astronomer, National Radio Astronomy Observatory. We're really eager to hear from him. There's a lot going on in that space. After that, we'll have 5G and Green Earth initiatives. That's a 2021 recap of a presentation made to the NSMA board in 2019. I'll be doing that, joined by Mariana Verlage Archibald, who's been helping with this entire conference, and is a sustainability consultant and environmental engineer, graduated from Harvard Environmental Engineering. And so we're going to talk a bit about that aspect and how RF interacts with that, how you can use RF to help restore or grow or help with your farming operation, but also how to be careful out there with it as well. And then we're going to hear from Mark Johnson on electromagnetic effects on spectrum management from the U.S. Navy standpoint. And of course, the oceans cover 7/10 of the planet. So when the U.S. Navy thinks about these things, they're thinking quite broadly. So stay tuned for that. And then we'll follow with an NSMA board meeting, which any board members will have a separate Zoom link for that. Otherwise, thank you all for your time and attention. We'll see you after the break, 1 p.m. Eastern time. Thanks again to George Kizer and JD for your superlative attention to this matter, which is a really growing interest from a whole variety of angles. Thank you so much.